is the section 15.2 lesson video for physical science, and as always, if you want my videos in one spot, just subscribe to my channel. So section 15.2 is about law of conservation of energy and converting energy from one form to another. So energy can be converted from one form to another. The process of changing energy from one form to another is called energy conversion. So for example, light bulbs can convert electrical energy that they get from like an outlet into thermal energy, because of course when you touch them they feel hot, and electromagnetic energy, because we'll talk about that a little more later, but light is a form of electromagnetic energy. Okay, so again, energy can't be created nor destroyed, but it can turn into different types of energy. So the law of conservation of energy states that energy cannot be created nor destroyed. When energy changes from one form to another, the total energy remains unchanged, even though many energy conversions may occur. So remember, it doesn't matter what type of energy it turns into, as long as the total amount of energy remains constant. Then we're still following the law of conservation of energy. So the gravitational potential energy of an object is converted to kinetic energy of motion as the object falls. So remember, we talked about this in the last video if you watched it. If you have a skydiver and it has a certain height but it's not moving, he has a lot of potential energy because he's really high up. Once he jumps out of the airplane, he starts losing height. So he's going to lose potential energy, but now he's gaining speed, so he's going to gain kinetic energy. Okay, so that's what's happening, is he's starting with only potential and zero kinetic when he's not moving, and then once he jumps, his height's decreasing, but his speed is increasing, and so that's what happens, is they sit there and they surpass one another. Alright, a pendulum consists of a weight swinging back and forth from a rope or swing. So think about like a grandfather clock. Okay, so you have like your pendulum is going back and forth, just like that. Kinetic energy undergoes constant conversion as the pendulum swings, because when the pendulum is at its lowest height, it's at its fastest speed. Again, think about a roller coaster. So when it's at its highest height, it's going to stop and change direction. So we have large potential energy, low kinetic energy. Then as it goes to its lower height, we have more kinetic energy. So again, potential, kinetic, and then they just sit there and swap back and forth as it goes back and forth. So when friction is small enough to be ignored, the total mechanical energy remains constant. Now anything you see green on here, this is something that apparently is not on the milestones exam that I was unaware of when I first made the PowerPoint. So we'll just skip over that. If I find out later it is on the milestones exam, I will go back and remake this video. I hope I don't have to do that. Alright, so Einstein's E equals mc squared says that energy and mass are equivalent and can be converted into each other. In other words, energy is released as matter is destroyed, and matter can be created from energy. That goes into when we get to nuclear, the chapter on nuclear chemistry. That's where we'll talk more about that. Law of conservation of energy has been modified to say that mass and energy together are always conserved. Because the problem is, if matter can be created from energy, that means some of the energy has to turn into matter. So then energy is not being conserved. So that's why law of conservation of energy says mass and energy together must be conserved. So that way we can still follow Einstein's E equals mc squared. So section assessment. Well, this was super short. So what does the law of conservation of energy state? Well, if we do the one we just talked about, it says that energy and mass together must be conserved. Okay, energy and mass together must be conserved. But the more common definition you'll get from textbooks is energy cannot be created nor destroyed. Alright, number 2. As an object falls in free fall, what energy change is taking place? So remember, when it has a height, when it's super high up, it has lots of potential energy, no kinetic energy. Once it starts falling, that potential energy goes down, but because it's speeding up, that kinetic energy goes up. So what energy change is taking place? Potential energy is turning into kinetic energy, because as that height decreases, that speed increases. Alright, so potential energy is changing to kinetic energy. So number 3, what did Einstein conclude about the relationship between mass and energy? Well, they can be converted in between each other, or you could just put E equals mc squared. That would be fine also, but they can be converted into one another. Either answer would be fine. So number 4, what type of energy change results when friction slows an object down? Well, we all know friction. When you do like this, what do you feel? You feel heat. Heat is thermal energy. Okay, so if you're slowing something down, the energy of motion is kinetic energy. So if friction's slowing something down, kinetic energy is being converted into thermal energy. Okay, kinetic energy is converted into thermal energy because you can feel friction when you do like this. All that heat you start feeling in your hands is from friction. Alright, so describe the energy of a playground swing at its highest position. So remember, think about a swing. I wish I really had something to show you instead of my arm. I'd probably look ridiculous. Oh well, that's fine. I'm a teacher. I don't care. So at its highest position, that means you would have a lot of potential energy, but because you're about to change direction, you're going to stop for a split second and have zero kinetic energy until you get going again. Okay, so the energy of the playground swing at its highest position would be lots of potential energy, but no kinetic energy. And then of course we can skip this one because this is what's no longer covered on the milestones. So hopefully you understand a little bit better about energy conversions and the types of energy.